Hello, Slavo from PUSopen here. Let's look at PUS Service 5. I'll first give you a brief overview of the PUS Service 5 and then I will show you a live demo of how to use PUS Service 5 in the PUSopen framework. So briefly about PUS Service 5, it's one of the 23 PUS services defined by the ECSS base standard. The PUS Service 5, or PUS 5 as we call it, sends short messages announcing different events in your system to the receiving side, like critical level of the battery, finishing of the long processing, readiness to start a new task, different error announcements. It depends on your system and software architecture. The service is called event reporting by the ECSS standard. So let's say that sender can be your main satellite computer and the receiver can be a ground station. But you can also send PUS 5 telemetry messages between any other nodes of your system, let's say from your payload to the main computer and so on. There are 4 levels of PUS 5 telemetry messages, 1, 2, 3 and 4. Level 1 is an informative event, while levels 2, 3 and 4 are low, medium and high severity anomalies. So let's say that your payload finished processing image data and you want to notify the main onboard computer that the data is ready for downlink to the ground station. You can send TM51 report with a custom message, let's say code 5, my data are ready, start the downlink. Another example might be when your payload hardware fails after, let's say, 2 years in space. That's a critical situation and the ground crew shall be notified immediately, of course. So once your software detects a failing camera or any other hardware, your system can send TM54 high severity anomaly with a custom defined message, hardware failure detected. And the ground crew can then decide what to do next. That's about it for the introduction into PUS Service 5. And now let's jump to the live demo. So in this demo we'll send TM51 with PUSopen from one application to another via socket, but in your application very probably you will send the message through the data bus between the subsystems on board, or from the test PC to the satellite, or from the satellite to the ground station and so on. So let's start with the sending side. As for all of the files where we are using PUSopen, we need to include PUSopen.h, and then we create our simple main function. We'll define some event data, so that's what will be sent together with the TM51. We also need some sort of transmission buffers. So when we ask PUSopen to send the data or telemetry or CCSDS packet, PUSopen will create a byte stream for us. It will generate a byte stream that you can send directly through your data bus, or in this case through the socket. So we need some buffer for that. Then we have a part here where we need to initialize the socket, but as I said, in your case there will probably be like initialization of data bus, and that will happen maybe at the beginning when your system will boot. And here comes the important part. So we need to initialize the PUSopen stack at the beginning. It can be during the system boot, it can be on command, it's totally up to you. But we need to initialize the PUSopen stack, and we need to initialize it by layers, because not everyone will use all of the services, will not use all of the layers. So basically we just need to initialize those layers that we are using now in this example. So here we are initializing 3 layers. The lowest one, FES, where we are encoding the packets, then the layer where we are sending packets, and then the layer which is validating the PUS packets. Now, as we said, the core principle of PUSopen is simplicity. So all you need to do to send a TM51 telemetry with the custom defined data is to call just one API, and that's this one here. It's called PUS5 TM. What this call does is that it will send TM51 with a predefined event ID and the data that you specify to some specific destination API ID. Now you may wonder, where is the event ID coming from? The event ID actually is defined by you in the XML file, which is translated by one of our tool called PUSconfig into the C code and then compiled together with your application. So let me show you that. This is the XML configuration file for the server part. The client part here will have its own XML file. And the definition for the PUS5 events is somewhere here towards bottom of the file. Here we have PUS event, it's ID 1, and as we said, we have 4 levels of the PUS 5 telemetry. So this one is informative event, so that's level 1. The description is only for like a ground crew, so the ground crew will get the same file as you have with your application, so they can then customize their output in their telemetry observation, telemetry reporting system. And there you fix the data size for the message. It's like 4 bytes in this case, and those are the 4 bytes that we have defined here. So it might be whatever you stuff into those 4 bytes. It's all up to you what you will put in as a custom payload, but you just need to fix the length of the message and then call this API here, PO PUS5TM, with a predefined event ID in your XML file, then the event data and the destination API ID. Now, as I told you at the beginning, the PUS will actually generate a bit stream for you that you need to store in some memory buffer and then send it out on the data bus. So this is the last part. It's this part here where we call PO frame, which is a functionality which is part of this fast layer of the lowest layer, where we are generating the bit stream, and then we call the server send and we send it to our client to the other part, and we close the server. So that is the sending part. Now let's have a look at the receiving part, which will be our client. So it will be server sending and telemetry to the client. We start again as usual with including PUSopen.h. We can write our main function here. We don't need argc in this case. Again, the same principle. We need to initialize PUSopen first. So here we will be initializing the lowest layer as we send, the layer which is sending the packets. The PUS user, which is the module which is handling the telemetry when it arrives for you, and then it calls the hook function, which we'll write in a minute, and then the PUS1, which is validating the incoming packets. Okay, so because we are in the emulation mode, we will open the socket. Now the client will be listening in the endless loop until the message is received from the server, and then it will print out the message. Here's the endless loop, where we are listening for whatever comes on the socket, and then we call PUSopen to accept the data which came from the socket. With this API, the data are actually inserted into the PUSopen framework, and then you kick PUSopen framework to process the received packet, to extract the PUS packet, and then call our custom handling function for the incoming telemetry, which we will write now. So let me finish the main function, so we have a code completed here. Right, so we close the socket. Okay, so this will be our customized hook function where we will process incoming telemetry. PUSopen framework is actually calling this hook function whenever a complete telemetry is received, so you can do your own custom handling of that received telemetry. And then inside a function we will do something very simple. We will just print out which telemetry is received, and then we'll print out the payload data of that telemetry packet. Okay, so let's build both examples. Build examples. Right, we went through. Okay, so you can see that in the first part here we are using a tool called POconfig, which is translating the XML file into the C code, and that went well. This is for the client part and this is for the server part. And then we are building both applications, and that worked well. Okay, so time for demo. We'll call our server first. Okay, and then we will call our client, which is the receiving part. Okay, and here we see that it worked. The PUS server connected to the socket and generated TM51. The bit stream went through the socket, and then on the other side, PUS client received the telemetry and printed it out in our custom handling function. Here you can see the custom bytes 1, 2, 3, 4 that we have defined on the sending side. So this is how you can send PUSopen telemetry messages with PUSopen. I hope you enjoyed the demo. We want to keep it simple for you. You've seen it. It's about 10 lines of code on the sending side and 10 lines of code on the receiving side. It's simple, but it's proven. PUSopen has a space heritage. It works flawlessly for different missions. Teams have used PUSopen on board of their satellite and as a tool for prototyping and testing their software on the ground. And we can indeed provide a training and tell you how exactly we comply with the space and communication standards. Thank you for watching. Visit us at PUSopen.com and do not hesitate to email us for a quick chat. Have a great day. Thanks.